Voyager 1, launched by NASA on September 5, 1977, was originally designed to explore the outer planets of our solar system. What was initially expected to be a mission lasting just a few years has turned into the longest operating spacecraft in human history. Now traveling more than 15 billion miles from Earth, Voyager 1 has crossed the boundary of our solar system, the heliopause, and entered interstellar space. Decades after it left the gravitational grip of the Sun, it continues to function, sending back data from the vast, cold darkness beyond the planets. It has now sent back a signal that has perplexed scientists worldwide. Recently, something strange happened. The spacecraft began transmitting data that did not fit into any known pattern. Engineers first thought this was a technical issue, possibly a degradation of its onboard systems. But as more data came in, it became clear that the readings were not glitches. The patterns exhibited unusual regularity, unlike the random static typically seen from cosmic background radiation or old instruments. The signal was structured, repeating at specific intervals, with variations that appeared intentional rather than random. It was unlike anything previously recorded from Voyager. For a moment, many assumed this could be a reflection or artifact caused by solar activity. But Voyager 1 is well beyond the influence of the Sun's solar wind. It's operating in the interstellar medium, a region filled only with sparse particles, magnetic fields, and the occasional cosmic ray. There are no known natural objects in its immediate vicinity that could produce such structured signals. And yet, the data stream remained consistent, almost like a coded message. Not audio. Not visual. But mathematical. This anomaly took the form of electromagnetic pulses that repeated with fixed symmetry. Some pulses had internal substructures, harmonic overtones, interference patterns, and fluctuating amplitudes that suggested a level of complexity difficult to dismiss. The plasma wave subsystem on board picked up disturbances that did not correspond with any known type of wave generated by plasma in interstellar space. Scientists noticed that the frequency of these pulses occasionally shifted, not randomly, but in response to the direction Voyager was drifting. It was almost as if the signal was aware of the spacecraft's orientation. Over a period of 3 days, this activity continued. The spacecraft transmitted these strange electromagnetic disturbances as they occurred. Then, just as suddenly as it began, it stopped. Voyager resumed normal behavior. The pulse patterns vanished. No new anomalies were detected. This temporary encounter, brief as it was, sparked debate across scientific institutions. What exactly had Voyager 1 encountered in interstellar space? One of the most surprising aspects of the data was its seeming origin from a fixed direction. While interstellar space is generally considered isotropic, meaning it looks the same in all directions, this signal appeared to originate from a point slightly offset from Voyager's current trajectory. When scientists analyzed the time-stamped data and direction of the spacecraft's instruments, they triangulated a possible location from where the signal might have been detected. This direction aligned with no known object, no pulsar, star, or radiation source previously catalogued in that region. Furthermore, Voyager's radioisotope thermoelectric generators, which produce electricity from the decay of plutonium-238, began showing a subtle increase in power output during the event. This was strange. These generators are designed to lose energy steadily over time. Instead, a temporary stabilization and slight increase in voltage output was observed. While not dramatic, it coincided directly with the time period of the anomaly. Power levels returned to normal afterward, but the timing was difficult to dismiss as coincidence. This raised even more profound questions. Could the encounter have transmitted some form of energy or information that interacted with Voyager systems? Could the anomaly be linked to an unknown form of particle or radiation, one capable of inducing temporary changes in the hardware without causing damage? Voyager's scientific instruments are old, built with 1970s technology, yet their simplicity may have played a role in detecting this phenomenon. Modern spacecraft use filtering software and digital preprocessing to clean data before it's sent to Earth. Voyager, however, sends much of its raw signal, meaning it may be better suited to detecting irregular and unfiltered activity, especially if the source of that signal is not natural. After news of the anomaly reached the public, astrophysicists, radio astronomers, and theorists began poring over the released data. No consensus emerged. Some believed the signal could be an artifact of a previously unknown type of interstellar turbulence, a fluctuation in the magnetic field interacting with Voyager's systems in a novel way. Others suggested that dark matter, still invisible and not well understood, could play a role in distorting electromagnetic fields. Yet another group proposed that the signal could be artificial. Although no evidence has emerged to support a definitive conclusion, what's especially compelling is that within a few weeks, Voyager 2, its twin spacecraft, traveling in a different direction through interstellar space, began detecting faintly similar fluctuations. The frequencies were not identical, but the waveform showed enough parallels to suggest a common origin. This gave rise to speculation that there might be something larger at work, possibly a network of signals or a spatial region filled with an unrecognized form of cosmic structure or energy. If that were true, it could reshape our understanding of space. Interstellar space has long been considered vast, empty, and static. But what if it contains a hidden structure, something not detectable through visual observation or conventional instrumentation? Something that could span light years and interact with spacecraft only under very specific conditions? The possibility of technosignatures, signs of alien technology, was raised by several researchers, though cautiously. SETI, Search for Extraterrestrial Intelligence. Scientists acknowledged that the signal pattern did not match any known natural phenomenon but were careful not to jump to conclusions. After decades of false alarms and disappointments, they remained skeptical. Still, the structured nature of the signal, its abrupt onset and disappearance, and its apparent connection to multiple spacecraft, make it impossible to ignore. For many, this moment echoes a deeper realization. We sent Voyager 1 as a passive observer, a machine to drift silently into the dark. But what if it has now become a beacon? What if Voyager has crossed into a region not entirely empty, but watched? Other theoretical explanations have emerged. One idea suggests that Voyager might have passed through a form of cosmic brine, a boundary layer in spacetime theorized by string theory. Another posits interaction with a primordial magnetic filament, one of many suspected to stretch invisibly across the cosmos. These filaments might be relics from the formation of the universe, and under rare conditions, they might interact with matter or emit signals that could mimic artificial patterns. Despite the theories, much remains unknown. The data from Voyager continues to be analyzed. A global coalition of scientists has requested additional time on deep space antennas to monitor for repeat activity. Every byte of Voyager's transmission history is now being re-evaluated, looking for overlooked anomalies or faint echoes of similar signals that might have been missed. Perhaps the greatest mystery is this: what if the signal wasn't meant for us? Voyager is a tiny object in a vast sea of space. What if it simply crossed a beam or signal path that was intended for something else entirely, a communication channel between unknown parties, or a relay of data far beyond our comprehension? And if that's true, what happens if someone, or something, realizes we intercepted it? As Voyager continues its silent journey, the event reminds us that even after all these years, space exploration is still full of surprises. The further we push into the unknown, the more we're reminded of how little we truly understand. This singular moment in Voyager 1's long voyage could mark a turning point in the story of humanity's relationship with the cosmos, a story that has only just begun.